Hi class, welcome to another day. As you can see, I'm gone again today. I'm going to be spending one more day at home with my family, just making sure everything is settled before I come back to work. But I wanted to show you some pictures of my family. There's my newest little one. His name is Jeremiah, right here. And then I have two other ones at home. This guy's name is Matthew, and there's my daughter. Her name is Joanna. So there's the three of them. They're all happy at home together. And here's my wife and I at the hospital. So it was a lot of fun, a good weekend of being together and stuff like that. I'm going to spend one more day Monday at home, and then I'm looking forward to seeing you guys again on Tuesday. But while you guys are here without me, let's learn the elimination method together. And I know that a lot of you said that you've done this before, so hopefully this is a review. There's three ways to find where two lines intersect. We could graph them, we could solve them by substitution, or we could solve them by elimination. So here on this next page, I've graphed both of these lines for you, and as I graphed both of them, as you can see, the intersection point is right there, so it's the solution that satisfies both of the equations. It's right 1, 2, 3 units, so the x-coordinate is 3, and the y-coordinate is up 1, 2, 3, 4, 5. So the solution is 3, 5. We got that by graphing it. We could substitute and also get the answer of 3, 5. But today what we're going to do is we're going to eliminate a variable, and we're going to get this solution 3, 5. So here's how you eliminate. On your notes it says that you're going to add the two equations together. So what I'm going to do is I'm just going to draw a line right here, and I'm going to add these two equations together. So what is 3x's plus 2x's? Adding them together, we get 5x's. Adding the next one up, what's a negative 5y plus 5y? Well, it is 0 y's, isn't it? All right. And then what is a negative 16 plus 31? Well, when I add both of those two together, I get a positive 15. So when I add up all the x's, all the y's, and the constants, I really get 5x equals 15. Because 0 times y is just 0, so I'm not even going to write that down. I just get 5x is equal to 15. So if that's the case, if 5x equals 15, I can divide both sides by 5 to get x all by itself. So x then is 15 divided by 5, which is 3. X equals 3. You can see in the third bullet point on your notes that it says, now plug that solution into any of the equations and solve for the opposite variable. So it doesn't matter. You can put it in for this one, or you can put it in for this one. It really doesn't matter. So let's put 3 into the top one. Okay? So it's 3x minus 5y equals a negative 16. 3x minus 5y equals a negative 16. And now we're saying that x equals 3. So I'm going to put this 3 in right there. All right? So it's 3 times 3 minus 5y equals a negative 16. So now let's solve for y. This equals 9. 3 times 3 is 9. 9 minus 5y equals a negative 16. I'm going to now subtract 9 from both sides, and I get a negative 5y equals a negative 25. A negative 16 minus 9 more is a negative 25. So finally, my answer, when I divide both sides by a negative 5, I get y equals a negative divided by a negative is a positive, and 25 over 5 is a positive 5. So my x-coordinate is 3, and my y-coordinate is 5. So I always write that as an ordered pair. X is 3, y is 5. And what do you know it? Look at what we got when the two lines intersected. 3, 5, and we got the same thing when we did it by elimination. 3, 5. We would get the same thing if we did it by substitution. All three of those methods find the solution for both of the equations. So there's the elimination method. You could always check this as well. Put 3, 5 into this variable, and you should get a negative 16 equals a negative 16. Put 3 in for this variable and put 5 in for this variable, and you should get 31 equals 31. So you could always check these if you wanted to. Let's go on to number 2. Let's practice this one. If you were to graph these, you would get the solution. The two lines would cross right there, which is right 1, 2, 3, 4. It's right 4 and down 1, 2, 3, 4, 5, 6, 7. Right 4, down 7. Let's see if we get this exact same solution by doing the elimination method. So the first step is we're going to add up all the variables. 5x minus 9x is a negative 4x. Boom! Positive 2y minus 2y is 0y's. And then we get 6 and a negative 22. That makes a negative 16 when you add those two up. Okay, so now again we have 0y's, which is just the same thing as 0. So a negative 4x equals a negative 16. Now that we know that, let's find x by dividing both sides by a negative 4. So x equals a negative 16 divided by a negative 4 is a positive 4. So the x-coordinate is a positive 4. I could put that into this equation, or I could put that into this equation and find the y variable. It doesn't matter. You do whatever you want to. I'm going to do this top one again. So 5x plus 2y equals 6. 5x plus 2y equals 6. Well, I now know what x is. X equals 4. So let's put 4 in there, and then we'll find y. So it's 5 times x. X is 4. Plus 2y. That equals 6. 5 times 4 is 20. 20 plus 2y equals 6. Keep on keeping on. Subtract 20. Subtract 20, and we get 2y equals 6, and a minus 20 make a negative 14. Lastly, divide both sides by 2. Divide both sides by 2. Y equals a negative 7. The x-coordinate is a positive 4. The y-coordinate is a negative 7. We write that as an ordered pair of 4, negative 7. 4, negative 7. There it is right there. Isn't that good stuff, everybody? That is good stuff. So 4, negative 7 is our answer. Did I circle it enough times? Or should I do it a couple more times? There we go. 4, negative 7 is our answer. Why don't you guys pause the video, try this one all on your own. Okay? Alright, after you tried this one all on your own, hopefully you got the solution of left 1, 2, left 2 units, and up 1, 2, 3 units. Left 2, up 3. Hopefully you got that as an answer. If you did not, let's check your work by doing it with me. X's, add them up, we get a negative 7x. Y's, add them up, and you get 0y. Constants, add them up, and you get 14. So negative 7x equals a positive 14. Divide both sides by a negative 7. Divide both sides by a negative 7. And x equals a negative 2. So I'm going to put a negative 2 into this one, or a negative 2 into this one. It doesn't matter. I'll put it into the top one again, because that's what I've been doing the whole video. 3x plus 4y equals 6. 3x plus 4y equals 6. So 3 times x, and x is a negative 2. Plus 4y equals 6. So a negative 6, because 3 times a negative 2 is negative 6. Plus 4y equals 6. Add 6 to both sides of the equation to get 4y all by itself, and we get 12. Divide both sides by 4, and we get y to equal a positive 3. So the x-coordinate is a negative 2, and the y-coordinate is a positive 3. Left 2, up 3. There it is, left 2, up 3. Okay? Hopefully you had success when you tried that on your own. Here's problem number 4, everybody. We're going to add up our x's and get 0 of them. Add up our y's and get 0 of them. Add up our constants and get 0 of them. Oh, man! So we end up getting 0 equals 0. Is this a true statement or is this a false statement? 0 does indeed equal 0, so this is a true statement. And everybody, if you remember from last week, whenever we get a true statement, that means the lines are the same. It's the same line. When the lines are the same, the answer for the solution is there are infinitely many. There is an infinite number of solutions because they are the exact same line. So what your answer is going to be for this one is, what is the solution? There's infinitely many of them. If you graph this line and if you graph this line, they're both the exact same line of this one right here. So infinitely many solutions for problem number 4. And our last one, here comes problem number 5. Again, we're going to add up the variables because when we do elimination, when we add them up, we end up eliminating a variable. So add up the x's and we get 0 x's. Add up the y's and once again we get 0 y's. Add up the constants and we get 12. So we end up getting 0 equals 12 then. 0 equals 12. Is this a true statement or is this a false statement? Well, obviously 0 is not the same thing as 12. 0 does not equal 12. So this is a false statement. When we ever do this by substitution or elimination, if we get a false statement, the lines are not the same line. They're actually parallel lines. Parallel lines never intersect, so what is the solution? There isn't one. The answer is no solution. The lines do not cross because they are parallel. So this is the answer for problem number 5. What's the solution? There is no solution. And as you can see when we graph both the lines, they're parallel. They have the exact same slope, so they're never going to cross. So that is the correct answer for question number 5. I'll be back with you tomorrow where we can answer any questions and go over things more in depth. But I hope that this video lesson made sense, and I hope you'll have success on the worksheet. Good luck, everybody. I'm looking forward to seeing you all tomorrow.